Okay, in this set of notes, we're going to be looking at section 6.4 and 6.5. This is going to be brief. 6.4 is on sampling distributions, and so there's some terminology and some examples and pages that I want you to refer back to. First of all, we have what's called a point estimator, a single valued estimate calculated from sample data, which is intended to be close to a true population mean, like, for example, a sample mean used to infer something about the population mean. Statistic, in this case, it's not statistics like our course, but a statistic is a numerical, description of a sample. So you have sample statistics, right? Or a sample statistic. You're going to be using this to infer something about the corresponding population parameter. And a parameter is a numerical description of a population. Make sure to look over sample statistics and corresponding population parameters. So what we're going to be doing in inferential statistics when we start doing uh, confidence intervals and uh, hypothesis testing and chi-square testing, for example. So in inferential statistics, we want to take representative random samples of the population and use the sample statistics as point estimators to infer something about the corresponding population parameters. Like, we're going to use the sample mean to infer something about what is the population mean within some error, plus or minus, right? So make sure you take over or look at this information about types of inferences, sampling distribution for the sample mean X bar. Make sure you look over examples 11 and the two tables that I have referred to here. Take a look over guided exercise 9 and also terminology on page 270. What we're going to see later is that the distribution of the sample mean is important for much of the inferential statistics we're going to be doing for the rest of this course. Here's your recommended homework. Of course, you have the answers for odd problems, so when you work on it, you can pop up the answers and take a look and make sure you got it right. Last section in chapter 6 that we're going to cover here is called the central limit theorem. And in your textbook, they call it theorem 6.1 because it's in chapter 6. It's referred to in general in stats texts as the central limit theorem. So for a normal distribution with mean mu and standard deviation sigma, the distribution of sample means X bar is also going to be normally distributed with the same population mean mu and a standard deviation of sigma over the square root of n. So notice this part right here, the sigma over the square root of n. Oh, my pointer's not doing it for this. But at any rate, the sample distribution has a smaller standard deviation than the population because you're dividing by the square root of n, which is n is the size of the sample. So this will be true regardless of the sample size. Now that's if we're working theorem 6.1 with a normal distribution. So what we can do, it'll be true regardless of the sample size. We can standardize X bar and use a z-table if we're doing a z-table other than a TI calculator or a calculator. We can standardize and use a z-table to calculate probabilities. Now you're going to be able to do this on your calculator if you look over the tech notes, right? Your graphing calculator. Note that the original X distribution and the X bar distribution, they're going to have the same mean. The standard deviation of your X bar distribution is smaller because we divide by the square root of n. You'll see something up to this point, we've called this standard deviation that we've been working with in this course. Here they use the term or definitions or the name of the definition, standard error. So you might see some problems pop up or some examples where they use standard error as opposed to standard deviation, but They're both the same. Take a look at example 12 on page 276 and look at the figures on the figure 6-35 on 277. All right, that's theorem 6.1, right? You have a normal distribution. Theorem, or the central limit theorem, theorem 6.2 in this textbook is a pretty powerful distribution because if you look at this part right here, for any distribution, if the sample size is n greater than or equal to 30, then the mean of your X-bar distribution, your sampling distribution, is going to equal the mean for the population mu, and sigma for your X-bar distribution, sigma with the little sub X-bar here, is going to equal the population standard deviation sigma divided by the square root of n, right? Notice here, as n grows larger, like the cutoff point is 30, right? But the bigger it gets, the more the X-bar distribution is going to fit the normal distribution. So if the sample size is greater than or equal to 30, the idea here is we can change X-bar values to Z values using a Z table, and then convert the X-bar values to a Z value using this formula right here. Z is going to equal X bar minus mu divided by sigma over the square root of n. Then use a Z table to find probabilities. Well, in your case, you're going to be using a graphing calculator, right? The commands of which you'll see provided in the notes, by the way. Um, So take a look at page 279 using this central limit theorem. Look at guided exercise 10 and so on. Look over the recommended material. So here's the important information I used at the end here to summarize it. All right. How do we know which theorem to use? Do we use 6.1 or 6.2? Well, if the original distribution is normal, we're going to apply theorem 6.1. If we don't know the shape of the X distribution, but the sample size is 30 or more, we're going to apply the central limit theorem, theorem 6.2. If we don't know the shape of the X distribution and the sample size is less than 30, we don't cover at this point how to handle that information. Here's your recommended homework right here for this section, problems 5, 7, 11, and 13. And again, these are odd problems, odd problems. You can click on the little box in when you get on your online text as you're looking over the problems. You can take a look at the problems, see if you can figure it out, and then click on the box and make sure you did it right.